Good question. Yep. And then I made a common denominator of a 38. And now I'll divide by 3. 1/3 of 42 over 38, which 42 is 3 times 14. So that's actually 14 over 38, which simplifies further to 7 over 7 over 19, right? And there you go. So solution is apparently 7 over 19, comma, minus 1 over 38. There you go. Yep. Oh, I added fractions. But you got to use your imagination. So 1 is 38 over 38, right? So we have 38 over 38 plus 4 over 38. 38 plus 4 is 42. So it's just adding fractions.
I still don't understand how you got rid of the negative.
Oh, I added, so I had minus 4 38ths here, right? Let me rewrite this. This is 3x minus 4 over 38 equals to 1, right? So we add 4 38ths to both sides. And that gets us to here. If we have a minus for the expression on one side of the equation and we move it to the other, the minus becomes a plus, right? So that's pretty much it. These are the two ways to solve two equations and two unknowns. You either add the equations to make one of the terms cancel, right? Which we did. So sometimes you can do that directly, like this one. You just add them and the things cancel. Lovely, right? Or sometimes you need to be sneaky. What was your name? Yeah. Beth Ann. So like Beth Ann, she's sneaky. So in a good way, in a good way. So, be sneaky like that and multiply by numbers to make it match up, right? This is a creative step, yeah? To see, to multiply that by 5 and multiply that by minus 3. Yeah? That's a creative step. And then we can do, so this is called elimination. Elimination is when you add or subtract the equations after possibly multiplying them by numbers to make them match up, okay? Elimination. The other way to solve these, though, I haven't showed you yet, is called substitution. All right? What's substitution? Substitution is when you solve one of the equations for one of the variables and plug it into the other one. So, and this also always works. So if I've got like 3x, minus y equals to 10, and I've got 4x plus 6y equals to 17, a problem like this, substitution is a nice choice. Let me show you why. So substitution works like this. So we label, but one of the things I should be doing here, and I haven't yet, is labeling this. This is equation 1, this is equation 2, right? Or you could just put 1 and 2. So equation 1, solves to give y equals to what? Y equals to, I move y to the other side, I move 10 to the other side, I get 3x minus 10. If we solve equation 1 for y, we should get 3x minus 10. Are we okay on this? So take equation 1, isolate y, you get y equals 3x minus 10. Yep.
It must be a negative 1y.
3x minus y equals to 10. I add y to both sides. I get 3x equals to y plus 10. Then I subtract 10 from both sides. I get 3x minus 10 is equal to y, which is what I wrote here. Okay, so solve equation 1 for y. And then what? And then we plug that into equation 2, then substitute into equation 2. What happens? We get 4x plus 6 times y. What was y? Y was 3x minus 10. That's equal to 17. Hey, now we have one equation, one unknown. We know how to solve this, right? So, yay. Let's do it. What we got? We got 4x plus 18x minus 60 equals to 17. 4 plus 18 is what? 4 plus 18 is 22. We got 22x is equal to 60 plus 17, otherwise known as, thank you, 77, which gives us x is equal to 77 over 22. That's 7 times 11, and that's 2 times 11, so that's actually just 7 halves, yeah? I'll allow it. All right, so, and then what's y equal to? Remember, it's 3x minus 10, so x is 7 halves, apparently. So we've got what? 21 over 2 minus 10, which I think is just 1/2, right? So solution is 7 halves, comma 1/2. So this method I just used here is called substitution. In the recommended homework, when it talks about substitution, this is what it's talking about. Any questions? Yeah.
Can you go over example 8 again, please?
Example 8. Wait, what part of it?
Where it says 3x equals 1 plus 4 over 38 equals 42 over 38.
Yeah? What about that? What's that?
Can you walk through that again, please?
This is just, so 1 is 38 over 38. So 38 over 38 plus 4 over 38 is 42 over 38. And then to get to the next line, I divided by 3, both sides.
So, but when you add the 1 plus the 4 over 38, shouldn't the 1 kind of go away?
It did. The 1 plus 4 38ths becomes the 42 38ths.
Oh, okay.
Uh-huh. Yeah. So, probably the smartest guy I ever met. He taught me the kind of physics which I ended up doing my thesis work on. But he doesn't care anything about history. He just doesn't care. And his family, and he's Spanish, so his family mentioned something about Bastille Day, and he like would mess up the date for it. He doesn't know like very famous Spanish history, and his family would be like, yeah, you're so smart. You don't even know the date of such and so forth. It's well known in Spanish history. So Daniel's typical response to his family would be 1/3 plus 3/7, go. And then he'd be like, you can't even add fractions. Shut up. But no, but it is true. Like adding fractions is just, it does take, if you don't see it, you don't see it, right? Like, so if you're hung up on this, it's like, you got to get like a, calculator or something. I don't know. Okay, so what's beyond 2 equations and 2 unknowns? Three equations and 3 unknowns, that's right. So example 9, it would be x plus y plus z equals to 10, and x minus y minus z equals to 20, and let's say x plus 2y minus z equals to 0. So this is 3 equations and 3 unknowns. All right? And 3 equations and 3 unknowns it's a little bit harder, but it's really the same principles that we've just been going over. So let me call this equation 1, equation 2, and equation 3. All right. What happens when we add equations 1 and equations 2 here? Yeah, there's a whole bunch of canceling, right? So it's super nice because when we add equations 1 and 2 here, the y's cancel, the z's cancel, we just get 2x equals to 30, right? So this gives us x equals 2? 15, right. So there's 1 down, 2 more to wrangle. Now what should we do? Yep.
Could you do 1 and 2 again? Do you have to add them? You can subtract them.
You could subtract them, but when you do that, what's going to happen is you'll get an equation that has all 3 variables. Well, okay, fine, yeah. Okay, sure, why not? 1 minus 2, see what happens there. I like it, it's not a bad idea, so that would give me what? Let me write it out down here. Otherwise, someone's just going to ask me a question in 3 minutes here. X minus y minus z. So I take those. You said subtract the equations. I like that. The x's cancel. We get 2y plus 2z. That was equal to 10. This was equal to 20. 10 minus 20 is minus 10. Hey, I like that. That's a nice equation. It's just got y and z in it. Right? It's kind of nice. I like it. Let's call that equation 4. Why not? I'd like to get another equation that just has y and z in it. How about this? I take equation 3 and I set x equals to 15. What's that give me? That will give me 15 plus 2y minus z equal to 0. What do we have now? Look at equation 4 and let's call this well, equation 3 with the x substituted into it. What do we got? Let me call this 5, just for the sake of reference. So if we look at equation 4 and 5, what we have is we've got 2y plus 3z equals to minus 10. And I'm going to move that 15 to the other side. 2y minus z equals to minus 15. What can I do now? Any ideas?
Subtract.
Subtract them, right? Subtract these equations. And that gives us the 2y's cancel. And we get 4z equals to minus 10 plus 15, which is 5. So z, yeah, what is it? Did I copy it down wrong? Which one?
Up there.
I mean, it's possible. 4.
Because you did 3z minus.
Oh, yeah. That's supposed to be a 2z. Oh, thank you. Yes, you're right. So I have inadvertently somehow changed that 2 to a 3 up there. That's not good. Fix that. That makes this a 3, right?
But where do you get the 3z from? Because you're minusing the z.
Minus a minus gives me a plus. It's because I'm subtracting the equations. So when I subtract, I'm subtracting a negative. You're fine. 5/3. And then what's y equal to? Pick your favorite equation, any equation, and plug in things, right? So x plus y plus z equals to 10. We now know that x is 15. We know y is, well, we don't know y. We know z is 5/3. It's equal to 10, so that makes y equal to 10 minus 15 minus 5/3, which is what? Minus 5 minus 5/3, which is, what's that? I believe that's minus 20/3. So the solution is 15 minus 20 over 3 and 5/3. So the quiz, I think there's a quiz next Tuesday, is that right? I believe I said that. So on the quiz, I will not ask you anything about 3 equations and 3 unknowns, just up to 2. There's a little bit more I need to teach you guys about 3 equations and 3 unknowns, so I wouldn't quiz on that yet. So have a good weekend, you guys. Let me turn off the camera here.
Are you sure that you released the right textbook on Canvas?
Not really.
You're not sure?
Is it better? Is it slower after the first, or am I still going too fast?
It's still a little fast. I'm just
Okay.
not good at math in general,
Uh-huh.
so I'll get there.
Okay. Well, don't be afraid to stop me. Like,